Hello, my name is Fernanda Sobral, and today I'm going to solve the problems from the partial exam number 2. So, I'm sorry, it's my dog again. So I'm going to start with the multiple option problems. So first it says, question A says, you wish to decrease the speed of a wave traveling on a string to have its current value by changing the tension in the string. By what factor must you decrease the tension in the string? So first we have an initial velocity, right? And we know that for a wave on a string, the velocity can be defined as the square root of the force divided by mu. And this value of mu will be a constant for the string. So this is velocity 1, right? And this is the force 1. And what you want to do is to decrease the speed of a wave to have its current value. So we know that v2 will be v1 divided by 2. So v2 should be equal to 1/2 of the square root of the force 1 divided by mu, which is the value for velocity 1 that we have up here. So from this, we can determine the value for F2, because we know that this should also be equal to the square root of F2 divided by mu. So we can raise everything to the square, and we get that 1/4 of F1, and mu goes away, equals F2. So this means it should be decreased by a factor of 4, which means that you should divide this force by 4 in order to obtain the velocity we are asked for. So that's question A. So question B says, the different colors of light we perceive are a result of the varying frequencies and wavelengths of the electromagnetic radiation. Infrared radiation has a lower frequency than does visible light, and ultraviolet radiation has a higher frequency. So, okay. I don't know if this is correctly explained. If this is correctly made, it's kind of horrible over there. So it's what we just read. The primary colors are red, yellow, and blue. So we know that red should be close to infrared. Let's suppose that this is a visible light. Okay, no. Yellow and blue. Okay, so order these colors by their wavelength, shortest to longest. So what we can see here, well, the diagram clearly describes what we are asked for, because we can see that the wavelength is smaller here and larger here. So the answer should be blue, white, yellow, red. But it's important for us to use a formula. So we can use a formula that says that the speed of light equals the wavelength times the frequency. And here we know that the wavelength is inversely proportional to the frequency. So if the frequency increases in this way, the wavelength will increase in this way. So the order from shortest to largest wavelength is blue, yellow, and red. And that's it for question B. Then we have question C, which is a small problem. And it says, you stand on the curb waiting to cross the street. Suddenly, you hear the sound of a horn from a car approaching you at a constant speed. You hear a frequency of 80 Hz. After the car passes by, you hear a frequency of 72 Hz. At what speed is the car traveling? So for this, we know that we have a formula that the frequency that you hear should be equal to the frequency times the speed of sound plus minus the speed of the source, but you are not moving. The speed of the observer, sorry, which is you, but you are not moving, so it's still, divided by, again the same, plus minus the velocity. So we know it should be negative if the car is approaching you and positive if the car is going away from you. So we have two options, right? We have 80 equals f times 343 divided by 343, and in this case it should be minus because it's approaching you, the velocity. And the other one is when it's going away from you, which should be 72 equals the frequency times 343 divided by 343 plus the velocity, because in this case it's going away from you. So we can join these equations either by taking away f or by dividing them. In this case, I'm going to solve for f in both cases and then equal both equations. So we know that 80 times 343 minus the velocity divided by 343 should be equal to 72 times 343 plus the velocity divided by 343. And here we have an equation that is in terms of b. So we know that we can solve for b, and the velocity should be equal to 18.05 meters per second, which is 18 in the answer we have in the problem. So, question D, if I can ever find it in my pictures, here it is. It says, a sound meter placed 3 meters from a speaker registers a sound of 80 decibels. If the volume on the speaker is then tuned down to so that the power is reduced by a factor of 25, what will the sound meter read? So in this case we know that the sound level cannot be directly used in the formulas we have. So we must first go to the intensity. So if we have an intensity of 80 decibels, this is letter D. This should be equal to 10 times the logarithm base 10 of the intensity in this case, which we will name intensity 1, divided by the minimum intensity, which is intensity I0 in this case, right? So we obtain from here that the intensity is equal to 1 times 10 to the minus 4 watts per meter squared. And we also know that intensity should be equal to the power divided by four by r, right? So in this case, we know that the second power should be equal to 1/25 of the first power. So the second intensity, as it is a direct relationship, should be equal to 1/25 of the first intensity. because this doesn't change, the radius won't change. So this should be equal to 4 times 10 minus 6 watts per meter squared. And it's asking us to obtain again the sound level. So the sound level 2 should be equal to 10 times the logarithm of this value here, which is the intensity 2 divided by the minimum intensity, which at the same time should be equal to 66 decibels. So that's the answer for problem D. And question B, sorry. Question E is a little bit shorter. It says, what has the greatest effect on the speed of sound in air? And our options are temperature of the air, frequency of the sound, wavelength of the sound, and pressure of the atmosphere. So what will have the highest impact will be what changes the most the medium through which the sound is going. And in this case, what changes the most is the temperature, as it increases the kinetic energy in the particles and makes it move faster, therefore having a greater effect on the speed of sound on air. So that's it for the questions.